The audio quality in this video might be a little poor. I apologize for that. But let's begin. Now you have decision theory ka second part, which is single stage and multi-stage. We focused on single stage. Now we have to focus on multi-stage. Multi-stage is pretty simple. I have at one point I can make two decisions. I can make three decisions. I can make four decisions. So if that's the case, then what should I do? Well, multi-stage decision making can be divided into two parts: decision nodes and decision nodes and chance nodes. This is a little confusing if you cannot understand it in the first go, but I'll try my best to explain it as precisely as possible. You can think of it in a way that the word chance means a possibility, and by possibility I mean percentage, possibility, probability, percentage probability. While I say decision, when I say decision, you can think of, well, decisions के synonyms I can't remember, but decisions are decisions. Decisions are, I guess, actions. So when you're making any decision, you'll be using this box. When you're having a क्या बोल सकते हैं, a confusion as to which decision to take, because I have a probability attached to it, a percentage attached to it, a possibility attached to it, I'll use a chance node. I'll take an example to explain it to you nicely, and then you'll able to understand the various rules of why to go from right to left and so on. I'll explain it to you. We have this question: we are drilling a well for water. So either we can dig till 20. When we dig till 20 meters, there's a 70% successful chance okay, I'll get water. Percentage, keep that in mind. 70% chance that I will find water. Matlab, what does it mean? The remaining 30% chances I will not find water. Keep that in mind. Then 25 meters there is a chance, 20% chance of success. Success is what? Finding water. So when I dig till 25 meters, I have a 20% chance. And if no water is found at the end, anywhere after digging 20 meters or even after digging 25 meters, I have to pay 15,000 rupees for a tanker, water tanker. At the end of the day, I want water. I cannot live without water. So I'll either drill or either pay. Okay. Now rupees 500 is the per meter cost of drilling. This is also additional information. Now, uh, I'll find I'll find an empty page so that I can explain the whole process. It's better to do it on an empty page. Okay, here it is. So think of it in a way. You'll always start with a decision. You will always start with a decision. You can think of that in a scenario that whenever you begin, you will never have a percentage with you. Okay, oh, there is a chance of that, there is a chance of that. No, you'll always start with a decision, and after taking one of the two decisions, you'll be confronted with percentages or probabilities or chance. So the first decision box is, now I have, think about it. You read the question, I read the question for you. Think about it. I have a drilling ka choice, or I can pay for it as well. I can pay for 50. I have 15,000 rupees. I can pay for it, but I can also drill. So if you think about it, you have two decisions. I can either pay for water, or I can drill for water. Correct? Either pay or drill. Now, as I see, you can see here, do not drill. That means pay. If I am paying, then I know for a fact that I have to give 15,000. There is no going away out of it. There's no way out of it because I need water and I'm not drilling, so I'll have to pay 15,000. So that is your first ending per se for a decision tree of sorts. Then the next thing is, now you're drilling. So how much can you drill? You can either drill 20 meters or 25 meters. Well, why either? You can first start with 20, and if you find water, then you'll go ahead with 25, right? So let's start with 20 meters. So that is your next criteria process. Drill for 20. Now here there comes the chance node. Why? Because this is not in your control. There is a probability attached to it. What is the probability? Either I will not find water or I will find water. This is a 70% chance or a 0.7 chance of finding water, and there's a 30% chance or 0.3 chance of not finding water. Now if you think about it, I found water now, तो हो गया, it's ended. At the end of the day I needed water. Either I can pay for it, I drilled for it and I found water. If I found water, that means इधर कुछ value आना चाहिए. What will be the value? If you remember, I said 500 rupees per meter का drilling charge. So 20 meters का drill करने का how much charge? 5 2s are 10,000. So 10,000 is my drilling cost. Then next 30% पे we now again will have a decision to make. Why so? I'll tell you. See, here if you look into it, हमने 20 मीटर तक पहले सबसे पहले in the first decision we could have not drilled or we could have drilled. Now after drilling for 20 meters, my option to stop drilling has not gone away because I have not found water. I don't want to incur that additional cost, right? I don't want to go ahead and drill ahead. So now I have two decisions. Either I do not drill or I drill for 25 meters, 25 meter drill. तो अगर देखोगे, if you look carefully, it's kind of mirroring this. Where I could have paid or I could have drilled. After drilling also there is a chance. I do not drill, I can drill. So if I do not drill, then what will be my cost? I need to pay for water because I haven't found it. Water costs 15,000 rupees. So 15,000 to rahega. But at the same time I drilled for 20 meters. So I have to pay for that as well, which was 10,000. So 10,000 plus 15,000. 25,000 will be my cost here. Here 25 meters drilling mein, either now again there's a chance of finding water at 20%, which is 0.2, or not finding it, which is 80% or 0.8. What will you do if you don't find water? You will have to pay for it, 15,000, plus you will have to pay for the drilling charges. You drilled for what? 25 meters. 20 plus 5, 25 meters. And 25 is what? 500. So 25 is a 125. 12500, which adds to what? 27,500 of cost. This has ended. I did not find water. I paid for it. Or you found water. A low probability, but still a probability. 0.2 mein you found water. So you don't have to pay for it. Now, what will be the cost? 25 meters drilling, 500 meters drilling, 12,500 rupees is my cost. Simple as that. You go ahead, you see the chance, then you'll wait and you say, am I going to take a decision here or has it ended? If you think about it, when we were here and there was 30% chance of not finding water, my objective was to find water or at least have water, but I did not find it. So I cannot have an ending. So I'll need to take a decision whether to drill or not to drill. And if I go with not to drill, then what will be my cost? But this is just a tree. Now how to use this? I'll go back to the original page so that I'll be better able to explain it. Now here is the point where you go from right to left. You number the decision nodes from right to left. So this is decision node 1, D1, then decision node 2 is D2 here. Why right to left? Think about it. If you have an answer, then good. If you don't, then listen carefully. Here, if you think about it, I need to take a decision. Either I go with this or I go with this. But if I were to take a decision here first, I would have, let's say I took a decision here, do not drill. I know my cost would be 15,000. If I take a decision of drilling and I found water, I know my cost is 10,000. But if I don't find water, I don't know my cost. How will I know my cost? If I don't know at this point what decision I'm going to take, how will I know what cost I'm going to incur? See, here I know that this is a decision and this is the cost. This is the decision and then this is the cost after the chance. But here I don't have a cost. You can say that, okay, if I go from this and I'll use a pencil for this, if I can find one. Okay, I can't find a pencil. But if you think about it, okay, I can still say that, okay, this entire structure of sorts, a flow from here to here is an ending, and a flow from here to here, here, and then here, and then here, it's an ending. Acceptable. But why make life difficult for ourselves? If we had three options here, if you can see, we have three options: either drilling 25 meters and getting water, drilling 25 meters, not finding water, and not drilling at all, directly buying. Why not simplify it for ourselves? Why take this long route and then divide it into three parts? Why not just go here and say, okay, let's just figure out what decision I'm going to take here, because that decision is not going to change regardless of whether I take this decision, right? At the end of the day, if I drill and I do not find water, I have to take this decision. So I know for a fact that I need to take that cost out. So why not do it first and then go here? This is applicable everywhere. If you think of it here, this is a little bigger, let me just get the focus, bigger table. I have two decisions, investment A, B. I know for a fact that at this point, I will either decide to stop investing or invest in B. And here I'll either stop or invest in A. If I were to not take these decisions, I would go how? I would go from here, investment A, here, then here, that would be one, then here, too much here, right? It's a little complicated. So let's make life simple. We go with decision node 1 first and decision node 2. How to take decision here? Very simple. Firstly, we have, let's write decision node 1, comma. Now, what are the options that I have here? The options are drilling to 25 meters or directly buying. We write those down: drilling 25 and do not drill and directly buy. We know either end hai, I have this end. By not drilling, by directly purchasing, we have 25,000 ka cost, right? Now drilling, may either I'll incur 12,500 ka cost or 27,500. But which one of the two? I don't know, but I do know the probability. There's a probability of 0.2 of this happening and 0.8 of this happening. I write those down. 0.2 of 12,500 and 0.8 of 27,500. The probability is 25,500 after calculating. Does this look familiar? Yeah, it is the expected principle, the EP. Yeah, expectation principle, very similar. So you multiply 24,500, 25,000. Now, I'll ask you a very simple question. These are costs. Which one will you take out the two? Obviously the lower one, because it's cost. Cost, we need to lower this. At all times, we are going to work to lower our costs. So this means at decision node 1, they should drill. The company who's finding water should drill further. Even if they do not find water prior to here, they will drill here. That's your decision node 1. They should be drilling up to 25 meters. Now decision node 2. Decision node 2 pe kitna hai? We do not drill. We drill for 20 meters and find water and not find water. Okay? Those are the two decisions. Do not drill pay. We know that 10,000 is our conclusion. Why have I written 15 here? It should, yeah, 15,000 actually, not 10,000. 15 is correct because cost of water is 15,000. Tankers. Or we drill to 20 meters. Now, once we drill to 20 meters, right? 0.7 chance of this happening, 10,000. 0.3 chance of decision 1 happening. Now here it is the importance of the simplification of going with decision node 1 first. Because I know that my decision node 1 cost is going to be 24,500 because it's the lower of the two. I know that 0.3 probability hai of taking decision node 1 and decision node 1 cost me 24,500. So I simply write 0.3 chance of incurring 24,500. बहुत simple है. Okay, it can be a little difficult. I am sorry if you are finding it a little bit difficult. I will explain again. Think of it in a way. Okay, I know this cost is going to happen because at the end of the day I need water here. So either I'll go with this or I'll go with this. Either I'll direct purchase or I'll drill. Now after calculating our probabilities and after evaluating, I came to know that drilling is always profitable, as we concluded here. तो मतलब 0.3 प्रोबेबिलिटी है कि ये होगा, हमको पानी नहीं मिलेगा, वी विल नॉट फाइंड वाटर, एंड बिकॉज वी डिड नॉट फाइंड वाटर वी वर गोइंग टू ड्रिल. तो ड्रिलिंग का कॉस्ट कितना आया 24,500. तो वाई नॉट से, वाई नॉट कंक्लूड दैट बिकॉज ए इक्वल टू बी एंड बी इक्वल टू सी, ए इज इक्वल टू सी. Because we are there's 0.3 of not finding water, and not finding water will lead to drilling 25 meters. Why not 0.3 chance of drilling 25 meters? Very simple. A equal to b, b equal to c, a equal to c. So that's what we do here, and we find out the value 14,350. So here, if you see, the cost of not drilling is 15,000, but the cost of drilling 20 meters is 14,350. So at decision node 2 we will be drilling to 20 meters. That's what we will suggest. We are just suggesting whether to do that or not to do it. It's their call. Yeah, so 14,350. Now the final conclusion is now the entire big thing. What did we conclude? At decision 1 they should be drilling up to 20 meters, and if they do not find water then they will drill up to 25 meters, after which if they do not find the water they will directly purchase. You write that the final plan of action, the company should drill to 20 meters. If no water is found, and it should further drill up to 25 meters, and if then also no water is found, the company is very unlucky. The company should drill, buy water. They have to, they don't have a choice. Yeah, so that is decision tree. Now it is very complicated in different ways. This is a much complicated version, this is also complicated, this is a simpler version, but every single story has the same thing. You have decisions, you have chance nodes, look at the chance nodes, calculate the profit, then go in the decision nodes, then write down the possibilities. Either you modernize or you do nothing, then you see which is higher. This is higher because this is profit. You go with the higher one. If you have losses, you go with the lower one. Basic rule. And you take the final decision. Game theory. Now that will come later. Thank you for watching.